Starting with today, we are learning vector addition graphically. Okay, physics time. Why do two arrows sometimes add up to one big arrow and other times almost cancel each other out? That seems unfair. What makes one arrow win over the other? Is it like when Lois and I argue about the TV remote, whoever's louder gets the channel? All right, seriously. Vectors are like arrows with a direction and a size. If I walk 3 steps east and then 4 steps north, do I end up wherever I want to be? How do I figure out that final spot without wandering around like a confused goose? Could I just draw them? That sounds easier than using math while my brain is still waking up. So here's the trick. Draw the first vector as an arrow. Then from its tip, draw the second vector. That's called the tip-to-tail method. The arrow from the start of the first to the tip of the second is the resultant. Why does that work? Is it magic? No, it's geometry. Translations don't change the arrow. If you slide an arrow without rotating it, it's still the same vector. Neat. But what about when they point opposite ways? Like if one vector is 5 units to the right and another is 3 units to the left. Do they fight and the bigger one wins with the final 2 units to the right? Is physics just giant toddler logic? How do angles come into this? If vectors aren't at right angles, we can use the parallelogram method. Put them tail to tail, complete the parallelogram, and the diagonal is the resultant. Can we find its length with the law of cosines? Yes. So can we always turn any tricky addition into a triangle and apply known rules? That sounds useful. Would drawing it first make solving easier in a test, or is it more about training your intuition? If vectors represent forces, could tiny changes in direction totally change the outcome? That's kind of deep. Makes me wonder, how often in life do small direction changes make a big difference? Okay, so summary, draw arrows, use tip to tail. The resultant is the straight arrow from start to finish, and angles matter. Now where'd I put my beer?